So if you guys look at today, we got chapter 14.3, which is one-sided limits. That's our goal number one, find the one-sided limit of a function. I essentially teach that as I'm teaching limits graphically and using the table. We talk about coming from the left-hand side and finding the limit, coming from the right-hand side, coming from the limit. Well, that's essentially what we're doing today. So that's really going to be nothing new. And then goal number two, determine whether a function is continuous. That's going to be super easy. If you can plug numbers in, you're going to be like, yes, it's so easy, Mr. Gotsch. So this section, in my opinion, is going to go real quick and real fast. Okay, so as I take a look, goal number one, find the one-sided limit. That's what these boxes are talking about here. Okay, so one-sided limit is called a left limit, and it reads like this. The limit of f of x as x approaches c from the left is equal to L. And the way I know it's coming from the left, so c's from the left, is because of that little negative there. Do you guys see that little negative sign and like where an exponent would be? That's not a typo. Okay, so when you see a c value with a little negative where the exponent is, that little negative means from the left. Okay, so that little negative sign right there means from the left side. And then same thing when we're looking at the next one. It says the limit of f of x. So this is called a right-hand limit. If I have the limit of f of x as x approaches c from the right, you see that little plus sign? C's from the right is equal to r. So again, that little plus sign where the exponent normally would be means from the right. Okay, so the little negative means from the left, the little positive means from the right. Well, again, that's kind of how I've taught it. I never showed you a little negative or a little positive, but that's what they're doing is they're breaking it down and saying, hey, we could find a limit from the left side or from the right side. Okay, and that's what we have here. Okay, it says use the graph to determine the limit. So they're going to give you a graph, and they want us to find A, B, and C here. Okay, well, A has that little plus sign. So again, A is my pink one, which is again from the right. And B is the limit of f of x as x approaches c from the left. It has a little negative there and with a little exponent. It's not really an exponent, but that's where the location of it is. Okay, so that's from the left. And then last but not least, this is what we've been finding in the previous sections. This is the limit of f of x as x approaches c. Well, if there's no plus or minus, it just assumes it's from both sides. Okay. So that is what we're going to do for examples 1 and 2. Super, super easy. Again, we've done this before, nothing new. So as we take a look, they're going to give you a value. So this was not written here. I'm going to give this to you. They're going to say, okay, find the limit of this function as x approaches c from the right. And it's going to give you the c value. In this case, the c value is going to be -1. Okay, so they give you this guy here. Well, what you can do is you guys can cut this down the middle here at -1. Just draw a vertical line here at x equals -1. And what I just did now is I separated into two sides, the left side and the right side. Now, it's very important that we get our sides right or we're going to get the answers wrong, right? So we got to know which way is the left and which way is the right. So again, if you struggle with that, your driver's ed instructor, Mr. Gotsch, will tell you if I want to go left, you can hold up your fingers like this. I'm going like this here, if you can tell. Okay. And it makes an L on the left side, and on the right side, it looks like a backwards L. Okay? Now, I've taught driver's ed for many, many years, and I'll say, okay, turn right, and then all of a sudden somebody goes left. Okay, so I know that this happens from time to time. You guys get your lefts and rights mixed up. So use your little L's. Okay. No, I'm kidding. That's probably not going to happen. But it does happen in driver's ed because they're frantic and they're scared. They think I'm a scary guy in driver's ed. I don't know why. Well, if I want to go from the right-hand side, follow your graph from, oh, see, Mr. Gotsch did it. This is the left. I'm frazzled here. And this is the right. So start on the right-hand side, Mr. Gotsch. And as I get closer and closer to -1, I got to figure out what is this thing approaching. So I got to figure out what that y value is. What's the intended height from the right-hand side? What do you guys say? As I get to -1, what is it approaching? What's over here? This thing's getting all the way up to 3, right? So we would say the limit from the right-hand side is 3. Okay? And now I want to do the limit as x approaches c from the left of this function. Okay, so I've got a little negative there. So follow your graph from the left-hand side. And as I'm getting closer and closer to -1, what's the y value stopping at? -3 right here. Okay. So we say the right limit is 3 and the left limit is -3. Well, the final answer for part C is, well, I want to know what the final limit is. What is the limit of f of x as x approaches c from both sides? Well, I compare the two. I got 3 equals -3. Are those equal? No way. They're not the same. They're different. And if they're different, what's my answer? The limit does not exist. There is no intended height there at -1. So we'd say D and E for short does not exist. Okay, so we have our limit from the right is 3. The limit from the left is -3. Well, from both sides, they're approaching 2 different values. There's no intended height of this function at this x value. Okay, now if I change the x value, it changes the question completely. So if I said, hey, what's the limit at 0? So here's x equals 0. Well, the limit from the left would be 1. The limit from the right would be 1, and I would have a limit then at 1. So understand when you change the x value, it changes the question. Okay? Changes your limits. Do you guys have any questions with that? That's pretty easy. Okay, so last but not least, we got example 2. Okay, again, it's going to be given to you what the c value is. So in this case, we're going to say our c value is 2. Okay, so that's going to be given to you. My math lab will give that to you. And now we want to find the limit of this function as x approaches c, and then from the right. So a little plus sign there. Okay. So again, I always like to draw in that line. It helps people visualize it. So I have x equals 2. So whatever that c value is, that's going to be where your vertical line is. Okay. And now I've just split it in half. Okay, Mr. Gotsch, which way is left, which way is right? Okay, this is an L. So this side is left. And this side's got to be the right. Don't want to mess that up again. I'm videoing this thing. So again, from the right, the little plus sign says from the right. So as I'm getting closer and closer to 2, what's my y value getting to? It stops right there. What's the y value? 4. So the limit from the right is 4. And we do it again. I want to find the limit of this function as x approaches c from the left. That little negative is starting on the left-hand side, getting closer and closer to 2. So I start on the left. My x value is getting closer and closer to 2. The y value is going up, and then it stops right there. What's that y value? Stops right there at 4. So the limit on the left is 4. Okay. Well, final answer. Final answer. I've got the limit of this function as x approaches c from both sides. Well, I take a look at these two numbers from the left and from the right. Is 4 equal to 4? You betcha. So what's my limit? 4. Okay? So again, if 4 equals 4, then I've got a limit. If the limit from the left and from the right are different, like in example 1, the any does not exist. Does not have an intended height or a limit at that value. Okay? You guys have any questions there? How easy is that? It's essentially the way I taught 14.1. Okay? We look from the limit from the left and from the right. They should be converging on the same y value. If they don't, d and e does not exist. Any questions, y'all? Okay? No questions. Last thing we got to do is talk about continuity. Okay? Continuity is basically looking at your graph and seeing if there's any breaks, gaps, or holes in our graph. Okay? When I look at these last two graphs, there's a big old gap in this graph. Okay? So we would say at x equals -1, there's a discontinuity there. It's not continuous. Okay? Same idea here. When I look at this graph, I see that there's a big old hole right there in my graph. There is a discontinuity. There's a hole right here at x equals 2. Okay? You guys have any questions with that? So continuity is continuous. Okay? So what I want you guys to think about is this a roller coaster you want to ride? Because if it is, it should have no gas, brakes, or holes. If I was riding this roller coaster, you would die. It would go, and right here it goes, ah, and I would fall to the ground and die because there's a big old hole in my graph. It is not continuous. Okay? The track, for whatever reason, is up there, and it is not got, there's a big old hole in my track. We don't want that. Same idea with this one. You go up, and then right here, and I'd fall to my death. We don't want that. So how do I see if there's a big old hole or gap in my graph? How can I tell if it's continuous at this certain x value or c value? Okay, well, the first thing they say is f of c is defined. When you plug it in, you should have a number coming back, meaning it's defined. If I plug in 10, I should get 5 back. If I plug in 100, I should get 7 back, or -2, or -3. Okay? If I plug in 100, I should get a number. It's okay that the number is 0. If I plug it in and it gives me something that's undefined, then there's got to be something going on in that spot. Okay, and I'll show you some examples there. Okay. Next one, it says the limit of f of x as x approaches c has to exist. Okay. Well, most of the time, you can find a limit from both sides, the left to the right, and it's going to give you that y value. Almost 99% of the time, if you plug in the c value and you get a number back, well, that means that limit exists. Specifically, the limit of f of x as x approaches c, your limit should be whatever you plug in, you'll get that y value. So, basically, all we need to do is plug it in. Plug it in. What's it? The c value. Okay? So they're going to give us a function there to say, is this thing continuous at c? So they give me a function here. People at home, I've got f of x equals x minus 2 over x squared minus 6x plus 8. And they want to know if it's a continuous at 4. Well, All we got to do is plug it in, plug it in. We want to see what f of c is. We want to find f of, in this case, 4. So anywhere that you guys see an x, I'm going to plug in this 4 value, this guy right here. And then I'm going to simplify. On top, I got 4 minus 2 is 2. On the bottom, I get 4 squared is 16. Negative 6 times 4 is negative 24. And then plus 8. So we end up with 2. And then what's 16 minus 24? 16 minus 24. Negative 8 plus 8 is 0. Well, what happens if you have 2 Snickers bars and you want to divide it into 0 groups? What do you get? You can't divide into 0 groups. It's impossible. So it's undefined. And if it's undefined, something's going on in that part of the graph, right? So we should know with a rational function, there's either a whole or an asymptote, right? So there's something going on right there at negative 4, or positive 4, excuse me. So that means it is not continuous. That thing is not continuous. We would say it has a discontinuity at 4. Okay, so it's not continuous there. We would say it has a discontinuity. Now, they could ask this a different way. They could say, where is the discontinuity at? That's basically saying, where does this thing have a gap, asymptote, or hole? Well, if I take a look at my function, again, we have a rational one. We should know what makes this thing undefined, right? If you're looking at a fraction, where are our restrictions in our domain? What are we looking for? What values can we not have? Where do we look? With a fraction, what can we not divide by? Can't divide by 0, so we would want to see what makes my denominator 0. If we factor this guy, x squared minus 6x plus 8, we know factors of x and x. What's factors of 8 that add up to negative 6? Negative 2 and negative 4. So then we would know that we cannot have positive 2 or positive 4. We would have discontinuities at those two values. So in our graph, we're going to have a hole or an asymptote at 2 and 4. Okay? Back with rational functions, we talked about if you reduce it, you remove it, and that's a hole. So we would say that's a hole, also known as a removable discontinuity. Okay, I'm not going to quiz you on that, but that's kind of where it would be going in calculus. So we would say 2 is a removable discontinuity. I say if you reduce it, you remove it, that's a hole, also known as a removable discontinuity. Big old open dot in your graph. The x minus 4 is the asymptote. Okay, so that's where our breaks or holes or gaps are. Don't really need to do that unless they ask you that question, but if they give you the C value, just plug and chug. It's just super easy. But this is another way to answer that question. If you get these two values and that's one of the C values, you know for sure it's not going to work. All right, let's take a look at the next one. I've got f of x equals x minus 1 over x cubed minus 1, and the C value is 1. Is it continuous there at 1? Well, find f of 1. Just plug in this 1 value anywhere you guys see x. 1 minus 1 is 0. 1 cubed minus 1, what's 1 cubed minus 1? 0. What's 0 divided by 0? 0 divided by anything? Anything divided by 0, I should say, is undefined. Let me rewrite that. UND for short. And if it's UND, this thing is not continuous. Okay, so if you find that it's undefined, if you're dividing by 0, this is bad, right? Anytime you divide by 0, you cannot do that in real life. All right. Maybe in the quantum realm you can, but not in real life. All right. Do you guys have any questions with that one? All right, so if I take a look at example 5. Example 5, I got f of x equals x squared minus 5 over x plus 5. And I want to see if is it continuous at 5. So one thing again I can do, just plug it in, So wherever there's an x, I'm going to put parentheses, and in the parentheses, I'm going to plug in this 5 value. All right, we know 5 squared is 25 minus 5 is 20, right? 5 plus 5 is 10, and 20 divided by 10 is 2. Boom. If I can plug that in, I got my intended height of the function. This thing is continuous here, right? So I definitely have continuity. So the answer is yes. It is. Too many U's in that. It is continuous here. If I plug in my number and I get a number back, that means yes, that is continuous, and that is not a hole. I don't have a gap or restriction in my domain. That thing is for sure continuous. Now, there is a continuity here. There is a discontinuity. Does anybody know where the gap, hole, or asymptote is in this graph? Does anybody have an idea? What makes this thing undefined? Yeah, -5. If I take a look, x plus 5 can't be 0. Okay, so if I ask you where's this thing have a discontinuity, where is there a hole in the graph, we would say at -5, because -5 plus 5 is 0, and you can't divide by 0. Okay, excellent. Questions, y'all? So that's pretty much the questions you're going to see on quizzes and tests. I will talk about this one just briefly because we always get the, well, what if? We have a piecewise function. So as I take a look, I do have a piecewise function here. I have f of x equals, I have x cubed plus 3x over x squared minus 3x. Okay. Here it says x cannot be 0 for that. Okay. And in fact, if I plug in 0 right now on the bottom, I would get 0 squared minus 3 times 0, which is, again, 0. It's undefined there. Now, what I have to do is identify, is that a hole or is that an asymptote at 0? Okay, you can do that a couple different ways. You can do it just by graphing it, or you can do it algebraically. If I'm looking at the graph of this guy, let's pull that up on the graphing calculator. Again, just going to give you a visual here. If I was to type this in, I would go to y equals. I'd use parentheses around my whole numerator, whole denominator. So I've got x squared plus 3x divided by x squared minus 3x. And then I would just get a rough sketch of what this thing looks like. So I'm going to go zoom 6, zoom standard. And again, it's just a rough sketch of what this thing looks like. Now again, we're trying to figure out, at 0, is this thing continuous? Again, looking at this rough sketch, Right now it looks continuous. It looks like that's filled in. But if right now, if I go second trace value 0, I've got a big old hole there. There's some kind of hole right there. Okay? Is there a limit there? Just looking at this function, is there a limit? Is there intended height? As you approach the right-hand side and the left-hand side, is it converging on a certain value? Yes. How do I find that value? Where is this hole at? Any ideas? I know the x value is 0. What's the y value? I know that's 0 something. What's the something? How do you find, go back to 14.1, how do you find limits when there's a hole? And plug in 0, I can't find it. What's another number? You could factor it and then plug in 0 and see what you get. Okay, let's do that. So I'm going to take a look at the top here. Again, I've got x cubed plus 3x. And then I've got x squared minus 3x. So Raman suggests, hey, we could factor this thing. Take out an x. That leaves me with x squared plus 3. And on the bottom, take out an x. That gives me x minus 3, right? Now the x's reduce. And now here's my function. I got x squared plus 3. I've got x minus 3. Now I can find that intended height. I can find the limit as x approaches 0 here. That's 0 squared plus 3. That's 0 minus 3. These guys would cancel or simplify. I would get 3 over negative 3, which is what, negative 1? So you guys okay with that intended height to be negative 1? The other option is if you don't want to do the algebra, well, you could pick a point very, 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 very close to 0. You could do like 0.00001. And you'll see that, yep, right there, pretty darn close to negative 1. So you got some options here to find out where that hole is. Okay, you can do a little algebra like we talked about in 14.2, or you can use kind of like the table idea that we learned in 14.1, plug in a number really close to 0. Okay, but again, if I plug in 0, it's undefined. Well, when I take a look at the next part of this piecewise, this says that y is equal to negative 1 when x is 0. Well, guys, that's a coordinate point at 0, negative 1. Well, that means that this open dot is now being filled in with that other part. Okay? So, is it continuous now at that graph? The idea is before just the blue one with the open dot, it was a discontinuity there. There was a big old gap. There's no way I'm riding that roller coaster. But now these guys here in green has filled in that gap, and now it is a continuous function there. Okay, so this thing is continuous at 0. Does that make sense? The blue one's the roller coaster ride with a big old hole there. No way I'm riding it, but the workers came in and put the track where it belongs, and now it's a continuous roller coaster ride. So this thing does have continuity. This is continuous. Okay? All right, ladies and gentlemen, any questions before we let you out of here?